Okay, welcome back. I'm just doing a bit of problem solving. I'm just going to continue on with it here. So the easy questions here are that a 90-degree angle is 90, at 2 right angle degrees is 180 degrees, and I'm just doing some simple problem solving. I'll probably use the calculator here and maybe even a table to help me out. And I want to just build the description to you here as well here. As you make up what's called a polygon, let's start off with a triangle. You can think of it as an internal angle and an external angle, okay, and so on. Up here you would have an internal angle and an external angle. Okay, now if you take all the external angles, as you go around the polygon, you must go around 360 degrees to get back to where you started from. Let's think about that really carefully in terms of an equilateral triangle. Okay, you would have 120 here. You would turn, which would turn you to this angle. Then you would have another 120 here, and then you would have a further 120 here. And you'd be back to where you started. Okay, so what it means basically is that your external is always equal to 360 degrees, or 4 90s. Okay. Now your straight angles add up. So for example here, your straight angles add up to 3 multiplied by 2 multiplied by 90. And then you subtract 4 90s. Always subtract 4 90s. And you get 2 90s, which is 180 degrees. Okay, and the next one, in a quadrilateral, you would expect 8 90s, take away 4 90s, and you're left with 4. Now don't be fooled by that. That number is just, it's a special case that these are both 4. Onto the pentagon, you would have 5 by 2 by 90, which is 10 90s. Again, take away 4, and you have 6. So with the pentagon, double that is 10, take away 4 is 6. With the hexagon, which is 6-sided, you have 12 take away 4, which is 8 right angles. The heptagon, which is 7 sides, will be 14 take away 4, which is 10. And the octagon will be 16 take away 4, which is 12. Okay, just lock in your focus there because it keeps drifting. Now show there's a linear relationship between the number of sides of a polygon and the sum of its angles in terms of right angles. Okay, so we have 3, 4, 5, and so on. So what is the linear relationship? Well, let's do our first difference here is 1. No, it's not, it's 2. Our first difference is 2, our first difference is 2, etc. Okay, and if we were to go, so the linear relationship is, now this is 3 right angles, so 3 sides. So what we want to do, 3, 4, so if we were had to go back to 2 sides, we would have gone to 0. And if we had gone back to 1 side, which doesn't exist, but you can pretend it does, 1 side you would have gone back to -2. If you'd gone back to 0 sides, you'd have gone back to -4. So I'm thinking it's 2s minus 4 is the number of sides. Now that was kind of tricky because we're used to being on term 1, but we were on term 3 in terms of sides. So, and we can think, does this work, by jumping straight in to saying, does it work for 3? Yes, you get 2, 3, 6 take away 4 is 2. Does it work for 4? 2 4s is 8 take away 4. It does. It works all the way down along, and that's the relationship. Now, you could have just said that the first difference equals 2, because that makes it linear. But then it says, and that the sum of the angles, so you could have just said first difference equals 2, therefore linear. We've gone one step further and we've worked out the actual number of right angles. So we have the number of right angles is equal to 2s minus 4, where s is the number of sides. We might need that over here when we start to graph. Okay, so let's graph. Number of sides. So the graph starts at 3. The domain begins at 3, and we're at 2. At 4, we're at 4. At 5, we're at 6, and so on. You can see that that's going to continue on like this. Nope, like this. At 7, we're here, and at 8, we're here at 12. Okay, I should have done that in pencil, but I didn't make any mistakes, so I'm okay. And we just, a great trick of linear terms, exactly linear terms, is just to join the first and the last. Okay. That's that done. Derive a formula. A nice way to have done it, another way to have done it is, instead of working all the way back to the 0th term here, would be to continue this on and use y equals mx plus c. If I had to bring this down here, we could do that. We could just use our compass to see where are we at. Let's see, where would negative 4 lie? And look at that, negative 4 would lie just there. So then we'll be using y equals mx plus c. The c is negative 4. The m is the slope, which is how much you go up for every 1, which is 2. And we call this variable here not x, but s for sides. Same as what I had over here. It just shows how wonderful this is. And y can be the angle measured in 90 degrees. Okay, that should be it. No, yeah, it is it. As always, I will see you in the next one.